Dr. Bevin, I think Mr. Sripudia is not here, or but his name is here. No response. Okay, without delay, because of the next presenter is waiting. So can you start for the next presenter ID? Is it okay? Or we have to wait again?
I think we should. I think we wait for a while for them because I think
we
after
have to follow the time limit.
Yeah, that's right.
Yeah. So okay, Mr. Sripudia, are you here? No response. Okay, better. If you allow, then we can start with next ID, number 66, Mr. Kanath. Is it okay?
Okay.
Okay, that's good. Mr. Kanath, you already know the rules and regulation about the presentation. Your time is 10 minutes per presentation, followed by 3 minutes question and answer. And so that is your presentation. So we can start. Okay, thank you.
Good afternoon, ladies and gentlemen. My name is Kanath Bindusitlak. First of all, thank you all for coming here today. Today, I'd like to present about numerical calculation of laminar flow in circular pipe partially filled with porous media using the finite difference method. Is the research of Kanath Bindusitlak, Lapipong Piansuwan, and Bandit Kitakong. My present will be in 5 parts. In the first part, introduction, the flow of fluids can be divided into 2 types. The cooled flow is the movement of top plate. Furthermore, the plate below it will not move. The Poisson flow is a flow in which the 2 flat plates remain stationary. Filter, heat exchanger, catalytic, and pneumatic are examples of Poisson flow to porous media in industrial impeachment. Suchio Fukushi studied the fully developed laminar flow in respiratory cross-section domain, so using the finite difference method. Sen Pu Hong et al. Studied theoretical investigation of the negative electrohydrological micropolar fluid flow induced by internal microparticle quick electrotation in two-dimensional pulsar flow. Adetayo Samuel E. Kunchevich studied inherent irreversibility in unsteady generalized cooled flow between parallel plates with variable viscosity, so using the finite difference method. Ifexera et al. Studied the pressure-dependent viscosity subject to Poisson and cooled flow via tangent hyperbolic model, so using the finite difference method. Almost all of the work listed above has something to do with the openness of the pipe wall. The inner pipe heat transfer emission to the outer pipe with infection. The porous wall is used and studied in this research to improve such a heat transfer. At a result, numerical simulation of laminar flow in the circular pipe partially filled with porous material for using the finite difference method. We examine the velocity and temperature profile inside the pipe and within the pipe wall. Let's go to the next point. Mathematical model. The physical model of fluids via porous media and porous media is dependent schematical in figure. Equation 1 and 2 are the governing equation for Navier and energy equation in fluid zone. Equation 3 and 4 are the governing equation for the Navier and energy equation in porous media zone. The boundary conditions in the fluid zone are equation 4a and 4b. Equation 6a and 6b define the boundary condition in the porous media zone. All of these are dimensionless equations. These are ignored in mathematical model. Equation 7 and 8 are the dimensionless of governing equation for Navier and energy equation in fluid zone. The dimensionless of governing equation for Navier equation and energy equation are equation 9 and 10 in porous media zone. The dimensionless boundary condition in the fluid and porous media zone are equation 11a, 11b, 12a, and 12b. Let's go to the next point. Finite difference method. The dimensionless governing equation was substituted with the finite difference approximation and follow Navier-Stokes and energy equation. We use the explicit finite difference method to solve to the problem. This is the finite difference of the Navier-Stokes equation or equation 13 and the energy equation or equation 14 in fluid zone. Let us define the time interval of finite difference and the Navier-Stokes and energy equation for fluid zone as equation 15 and 16. This is the finite difference of the Navier-Stokes equation or equation 17 and the energy equation or equation 18 for porous media zone. Let us define time interval of Navier-Stokes and energy equation for porous media zone at equation 19 and 20. Result and discussion: the dimensionless of velocity and temperature profile in left and right with increasing dimensionless pressure. According to the calculation result and the increased pressure cause an increase in velocity and temperature profile because the fluid will flow quicker due to the pressure acting on it. When the fluid flow fast, it will cause high temperature. The dimensionless of velocity and temperature profile in left and right with increasing dimensionless Ecker number. According to the calculation result, the increased Ecker number cause an increase in velocity and temperature profile because the candidate energy of fluid cause temperature according to the theory. The dimensionless of velocity and temperature profile in left and right with increasing porosity. According to the calculation result, the increased porosity cause an increase in velocity and temperature profile because the partially porous media promotes heat transfer within the system. The dimensionless velocity profile was increased as increasing pressure, Ecker number, and porosity because the fluid was decreased as according to theory. The dimensionless temperature profile was increased as increasing pressure, Ecker number, and porosity because the heat exchange between fluid and porous media was caused as heat transfer in porous media to be higher than non-porous media zone. Thank you all for listening. I want a pleasure belong here today. I will be happy to answer your question now.
Thank you, Mr. Khanat, for finishing your nice presentation within the time. So the forum is open for the audience. Please, anybody, do you have any question, please? Okay, Mr. Khanat, I have one question. Can you hear me?
Yes, yes.
Mr. Khanat? Okay. So regarding your simulation study, do you have any experimental uh, result to compare your numerical analysis that you have done? That's the simulation results with the experimental results. Do you have any validation in especially the energy conversion? Is it clear, my question? Mr. Khanat, can you hear my voice?
Not yet compared with the experiment.
Okay. So my question is, do you have any comparison with your simulation results and experimental results? Dr. Bevin, can you help me? That probably he may not understand my English.
I think his line is a bit bad. I think what I heard was he has not compared with the experimental yet.
Okay, okay. All right, it's okay. Anybody, do you have any question? Please. So if there is no question, or we can move for the next presenter. Is it okay, Dr. Bevin?
Yeah, that's good. I think Sri Punya is here already.
Okay, thanks. Yeah, okay. If Sripuni is here, the presenter ID number 94. So, Mr. Khanat, can you close your screen?
Hi, I am PID 94. Sorry.
94. Yeah, 94. Yeah. So, you will get your time 10 minutes for your presentation, followed by question and answer 3 minutes. So, I, along with Dr. Bevin, will conduct this session. Okay, so let's start, please, Mr. Sripunia. By this time, Dr. Bevin.
Yep.
Hello, Dr. Bevin.
Yes.
Okay, my in my place the net is also maybe problem sometimes. So if something happened, you will continue. Please continue for the next presenter after finish the previous presenter.
No
Okay.
worries.
I need your help.
No worries.
Okay, thank you. Okay, Mr. Sripunia, please start your presentation.
Thank you. Can you see my slides?
Yes, Sri Punya, yes.
Okay. Good afternoon, everyone. My name is Wapi Sivanya, Development Digital Labs, Mechanical Engineering, RMUTI Thailand. Today, I am here to present about the improvement of the thermal effectiveness of the two-bank heat exchanger in a porous burner with installed in the porous emitter. The topic is introduction, methodology, result and discussion, and conclusion. The advantage of combustion in a porous material are stability of the frame, high radiation output, and reduction of NOx and CO. The porous burner use are readily applied for many purposes, including heating, such as heat exchanger, for power generation, gas stove, and power sources. The two porous material to separate it is higher thermal radiance output between the porous absorber, PA, and a porous emitter, PE, which are the major criteria many engineers and researchers have been encouraged to conduct numerical and explained study. In the year 2080, we are the experimental study of the installation of a two-bank heat exchanger on a gas porous burner. To study the performance of the combustion mechanism and thermal efficiency. From result and discussion confirms that the T as the outlet zone of exhaust gas was the high temperature at 800 Celsius. It was found that the temperature profile T and effectiveness of the heat exchanger is an improvement of the thermal effectiveness. The PE is installed as an exit zone of the porous burner. It was found that T increases it is improvements of the combustion performance. From the experience of the PE of a gas porous burner, the PE was extended as the exit zone of exhaust gas below the thermal exchanger of two-bank tie to the objective improvements of thermal effectiveness of the two-bank heat exchanger and thermal efficiency of the gas porous burner.
Hello, Sri Punya.
Probably his net maybe not.
Having
He
some
already
technical-
out.
Is it disconnected, Praveen?
Yeah,
Yeah,
okay.
problem
Oh,
is
maybe not. His connection like dropped.
he is disconnected.
Okay, just wait for a few minutes. 1 minute. Let's see.
Okay, no problem. Okay, okay. Yeah, Dr. Bevin, already 10 minutes over. So should we go for next presenter? Because the presenter is not yet Mr. Sripunia.
Oh, sorry. Yes, yes, sir. I think we can go to the next. I think
Hello.
Rana is
Yeah,
here.
next presenter.
Yes, it's me. I'm ID 64.
next presenter, ID number 64. Yeah.
Yes.
Are you
Yes.
ready? Okay. So you will get
Yes.
10 minutes time for your presentation, followed by question and answer. Okay. So thank you very much.
Okay.
Please start your presentation.
Okay.
Sorry, Gitron, you're on mute.
Sorry. Can you hear me? Okay.
Yes, we can.
Okay. Good evening, everyone. I'm Amnoy Kitlatana. My graduated student at Faculty of Engineering, Mahidol University, Thailand. Today, I will present my paper title is Dependence of Cool Loop Pen Color on Household Cooling Load and Analysis of Loop Pen Deterioration. This is my outline. First, introduction. Second, methodology. Third, result and discussion. And finally, conclusion. I will start with introduction. Global warming and climate change are serious problems that lead to many changes in ecosystem. The second one shows solar irradiation in the world and Thailand. And next, in addition, electricity is an essential part of everyday life. Refrigerator and air conditioner are consumed significantly. Amount of electrical energy shown in figure 2. Next, roof coating surface are the most area building that can absorb solar radiation. Shown in figure 3, typical heat gain in summer of an uninsulated home. Cool roof paint or high solar reflectance can reflect various types of solar rays. Consists of ultraviolet, visible light, and infrared spectrum, and decrease heat that pass short inside the building, shown in figure 4. The purpose of study is to explore the impact color shade and coating deterioration of roof paint on solar reflectance and thermal emittant. Next, methodology. Study first, preparation of sample. Roof paint sample is various colored. 3 colors were often from 2 well-known commercial brands in Thailand, Band A and Band B. It comprises 3 colors, white, black, and red. Preparation of sample. Roof paint was prepared a mixed roof paint and water in the volume ratio is 9:1. And then spray on neutral double lumen roof tile. It was sprayed with paint primer twice and roof paint for 4-time layering, shown in the figure 5. Next, accelerated weathering. Characterization of deterioration of roof paint was measured by QUV accelerated weathering tester, a cycle tester accelerating for X hours. That consists of 2 steps following ultraviolet at 60 degrees Celsius for 4 hours and condensation for 4 hours. Next measurement is the UV measurement. UV with NIR spectrophotometer was used to measure solar reflectance with wavelength ranging from 300 to 2005 100 nanometers, and thermal emission was measured by Fourier transform infrared spectroscopy or FTIR, but value were calculated the solar reflectance index or SRI. And finally, calculate loop thermal transfer value following under equation. Next, result and discussion. First, solar reflectance characteristic. The figure 7 shows the performance of solar reflectance of each color at the different wavelength. The results show that the white color shade for both bands perform great solar reflectivity in both invisible and infrared spectrums. Indicative of lesser heat absorption, as consider the black and red color shades for both bands. They can only reflect the heat within the infrared spectrum with a lower percentage than white color. Next, accelerated vectoring. Accelerated vectoring test to perform to test simulate the natural age to equivalent time test. The sample were tested until 60 months of equivalent natural aging. The result specimen shown in the figure 8. A is band A and B is band B. The figure 9 shows the white color was declined. The solar reflective index or SRI decreased 5.58 and 4.48% of band A and band B. As explained that there are slightly percent decrease, so the accelerated vectoring effect to solar reflectance. And in terms of the back component or B, the solar reflectivity index decrease of band A differ fairly from the default, but the band B will be elevation to UV radiation, causing the black pigment to fade and increase the SRI at 48 months equivalent natural aging. The red color will be have SRI different to no more than 0.85 and 3.57% of the band A and band B respectively. So the red color was not significant different. Next, calculated loop thermal transfer value. And the heat that passage inside the building is studied by determining the loop thermal transfer value or RTTV. The results in the figure 10 show the relationship between loop thermal transfer value and equivalent natural aging. The white color coating loop in figure 10A found that the increase of loop thermal transfer value responding to 15.62 and 11.72% of band A and band B. The loop thermal transfer of backcoating band A was not significantly different after 1,224 hours accelerated vectoring. But loop thermal transfer value was decreased in the case of backcoating color of band B after 48 months of equivalent natural aging. The loop transfer of less coating band A and band B were not significant different. And finally, conclusion. This study and accelerated vectoring experiment of 3 colors consists of white, black, and red, and band A and band B. White color code was a higher solar reflectance in visible and infrared wavelength, giving in a highest reflectance at the initial time. After that, accelerated by QUV accelerate vectoring tester, the reflectance index was reduced. On the other hand, black and red coating would where the lower solar reflectance index due to their lower reflectivity. In the summary, white coating roof was shown to have more energy saving potential in the building. This is my references. Thank you. Do you have any question?
Mr. Umar, for your nice presentation. Audience, please, do you have any question? Okay, Mr. Umar, you have measured the effectiveness of your system, especially the cooling load. So how was the effectiveness? Do you have any comparison with any existing reference? Can you please?
Again, please, what do you mean?
Because you mentioned about the effectiveness about the cooling load calculation. So do you have any comparison with the
Yes.
reference value, that how much effectiveness in your cooling load calculation?
Cooling load,
Is it
RTV
clear, my
light.
question? Yeah. Is it
My
clear, my
cooling load.
question?
No. Again,
Yeah.
please.
Can we go to the result and discussion?
My cooling load were calculated by loop thermal transfer value by this equation. Do you have any question?
I think that's all. I think a professor was asking you what your efficiency, when you spoke about efficiency, what did you compare your results to? When you say, for example, I can increase by 30% your loading or reduce the energy loading by 30%, or do you have any figure? How much of energy can you save by using this cool roof paint? So, for example, you say I can save 30%. How did you say that? How did you compare with what?
It's not linearly comparing. Yes. If SR increase, loop thermal transfer value are decreased, but not linear. It cannot comparing. Not equation to calculate, compare that.
Fantastic. And why did you just choose these three colors? Because I think I saw silver color. You showed a silver color?
Yes, yes.
So why did you only choose red black and
white, black, and red. So white and black are reference color, and red is most using in Thailand.
okay.
Yes.
Fantastic, fantastic. Any other questions from the
Yes. Thank you.
any other questions from our audience? If no, I think thank you very much, Kitrana, for your good presentation. Keep it up and
Thank you.
good luck for your research. Thank you.
Thank you. สวัสดีครับ
Welcome. I think our next presenter is number 65, Dr. Nigran Homjong. I think we still have a few minutes. Yeah, you can just, I think, hold on, what's the...
Dr. Nigram is
Can you
here?
hear me? Hello.
Yes, we can hear now. Yes.
Okay. Good afternoon, ladies and gentlemen. My name is Pongmijo Panyoyai. I come from Major University, Chiang Mai, Thailand. Today, I would like to present my work, the title Design, Construction, and Test of Moving Bed Carbonization for Agricultural Utilization. The outline of my present consists of the first introduction, second material and method, the third result and discussion, finally conclusion. Corn is an important cash crop used mainly in the Iranian fish production. The world corn producing area are in the Brazil, United States, Europe, and China. In Thailand, this produce about 2.5 million tons per year, which is the corn crop 0.8 million tons. In this past, farmers in Thailand burn this residue to destroy, leading as the pollution of smoke, dust, and air pollution. However, corn crop after pyrolysis or carbonization can be converted to the biochar. It can be used to produce biogas or pellet fuel. Corn crop biochar can also used in the organic cultivation and reduce soil acidity. Normally, biochar is produced using a fixed bed pyrolysis reactor, such as fish kiln, small kiln, big kiln, and transportable metal kiln. Usually, it takes a long time to reduce what has high cost. Therefore, there is an idea to create the moving bed pyrolysis reactor. What short residual time can reduce the energy input and will be able to increase the production rate. As the design concept, the moving bed pyrolysis used in a 1 horsepower electric motor was used to actuate the biomass. Its pyrolysis chamber 280 liters made from stainless steel could handle 30 kilograms of corn cobs. The heat source comes from the combustion of cooking gas. Temperature is in the range of 450 to 550 degrees Celsius. And the cooling pipe is coiled into a spring made from the stainless steel pipe. The moving bed pyrolysis reactor prototype dimension approximately 1 meter wide, 2 meters long, and 1.2 meters high. The weight of it about 150 kilograms. at the table show chemical and physical property of corncob used in this work. The moisture contains about 9%, size of corncob length about 2 inch, the bulk density about 110. Test method. The first to fill about 30 kg corncob into the reactor chamber. Second, the gas burner was ignited to heat a reactor. The third, electric motor was switched on to rotation. The fourth, maximum pyrolysis residence time of pyrolysis reactor was 1.5 hours. The valve of chamber was opened to rest the moisture and volatile matter out of about 30 to 60 minutes. Once temperature reached 300 degrees Celsius, some corncob were converted to biochar. The temperature continued rise 560 degrees. The weight of biochar cooking gas, charcoal, and wood vinegar before and after experiment were monitored, while the pyrolysis temperature and residence time were recorded throughout the process. The test of moving bed pyrolysis reactor will carry 30 kg of corncob, show satisfactory result, can generate pyrolysis to 600 degrees Celsius. The electric motor to work well. Process of corncob was carried out in 2.5 hours. The yield about 9.5 kg of biochar. About the temperature compared to fixed bed pyrolysis reactor from observation. At the start to process, the moving bed pyrolysis reactor could produce higher pyrolysis temperature than fixed bed pyrolysis reactor. However, after 30 minutes, the pyrolysis temperature was similar. From the test, carbonization was found to work well, provide high yield of biochar in 2.5 hours, and achieve pyrolysis temperature up to 600 degrees Celsius. Finally, I would like to acknowledge the support from Nature Research Council of Thailand under the Thailand Chinese the Energy Research Center and School of Renewable Major University were thanked to provide facility and equipment. Thank you for your attendance. Do you have any question?
Hello, thank you for your presentation. Any audience, you have any questions? I have a few questions. Why was this research, for example, what's the difference between fixed bed pyrolysis and moving bed pyrolysis? Why did you do the research? What are the advantages of moving bed pyrolysis?
Again, please.
So you said you compared with moving bed pyrolysis. That is your research?
Yeah.
So you also have a fixed bed pyrolysis. So what is the major difference between these two?
Or major difference? Yeah, major difference. wood vinegar of moving bed pyrolysis register was higher than the fixed bed polyester by an average of 20%, but the char and pellucid gas nearly same.
Okay.
Different, yeah. Different as the wood vinegar.
So what do you do with the wood vinegar? Is it a product that it is in demand, or so the major project was to get biochar, right?
Yes.
So in this research, you found that the biochar is not much, is the same, but only the yield for wood vinegar is higher,
Yes.
20%.
Yeah.
Fantastic. And why did you choose any other product? You only use corn. Did you use any other?
At the my test, we use only corn cob.
Only corn. Okay.
Yeah, only corn cob. 30 kilogram. We test 3 times.
Thank you. That's good. That's good. So do you have any idea of any plan to use different biomass like sugarcane?
The next I think I use a different in Thailand many residue such as the some wood or some palm.
Fantastic.
We can
and
use.
The pyrolysis gas. So how do you capture the gas, or what do you do with it? What is the use for that?
We use the gas. It means LPG gas or cooking gas.
Okay, so use it for heating again. The pyrolysis gas, the product. From your slide, you have a pyrolysis gas. So you use it for heating.
Again, please.
Oh, I'm looking at your chart here. So you have your product, your corn cob, charcoal,
yeah,
wood vinegar, and your pyrolysis gas.
Yeah.
So the green one is moving bed and also fixed bed. Okay. So it's similar. Only the wood vinegar is higher. No worries. Thank you. Thank you for your presentation. Any other questions?
Thank you.
Professor, any questions? I think we still got about 5. Thank you so much for your presentation. Maybe we'll go to next presenter. Thank you, Doctor. Thank you.
Thank you.
Good presentation. Thank you. So our next presentation, paper ID 81. Okay, you have another 2 minutes to just get ready, and we'll start in about 2 minutes.
Yes. Wait a second.
Sure.
Okay.
Okay, you ready? Okay. So our next, good afternoon all. Our next presenter is Mr. Ginyoshe Arya.
Yes,
So your paper number ID 81, effect of temperature during coelestral cultivation,
Xylostera.
novel pilot scale. Carbon dioxide, atmosphere. Fantastic. So yeah. So you're ready?
I'm ready.
Okay, you can start.
Okay. I'm not gonna bore you. Good afternoon, everyone. I appreciate you being here. My name is Dinasho Ariyanande. I'm studying for master degree in mechanical engineering at Kasetsart University. Let's jump right into today's topic: effect of temperature during Xylostera cultivation in novel pilot scale tubular coil photobioreactor in carbon dioxide atmosphere. I'm not going to bore you with the stats and numbers. As you have already known, carbon dioxide is a greenhouse gas that is thought to be a cause of global warming and is often released freely during industrial operation, such as combustion of fossil fuels. Because microalgae have a high capacity for photosynthesis, they can convert carbon dioxide into biomass. Biological carbon capture and storage can decrease carbon emission from an industry stack gas into energy-rich biomass, which may also have additional value as a chemical feed and along those lines. The objective of this research is to create a model of tubular coil photobioreactor for culturing microalgae Xylostera sp. Find the optimal growth temperature, study the effect of carbon dioxide gas on growth, and carbon dioxide uptake rate. Let me start by giving you some detailed experiment. The details about select algae strain Xylostera sp. TISTR 9427 was received from Agal Excellence Center at Thailand Institute of Scientific and Technological Research. Xylostera sp. was cultured in sterilized water enriched with Pg11 medium. Culture was grown in 10 cubic decimeter carboy and kept in place in the constant temperature room. Inoculation time was 14 to 21 days, and the sample was taken in the UV room to calculate the volume for starting at the optical density of 0.05. Every week, 0.05 cubic decimeter of microalgae sample was collected, and each measurement was repeated 3 times. The specific growth rate was determined by optical density. It was monitored through spectrophotometer measurement of culture media. Growth rate were estimated using the regression equation. Productivity: biomass was taken from cell and filled through a p-dye gas microfiber filter at 338 cool in the desiccator and reweighed. Biomass productivity was obtained with this equation. Microalgae could absorb carbon dioxide by diffusion, and many possess active carbon uptake rate systems that could absorb bicarbonate. The harvesting of microalgae biomass has been centrifuged by Ecuador Thailand and sent for carbon analysis. Carbon uptake rate was determined by using this equation. This novel-built tubular coil photobioreactor has been designed for lab scale and consists of tubular coil and vertical bubble column. The tubular coil reactor has extensive distance that increase the distance time between carbon dioxide and algae, so that more carbon dioxide can be dissolved. Moreover, the tubular reactor has small diameter, so that the algae is thoroughly subject to illumination. The bubble column is assembled to the tubular coil reactor to increase high gas transfer rate. The microalgae culture is pumped from a buffer tank to the top of the tubular coil by magnet pump, where it will flow by gravity to the coil bottom, then return to the surface of the buffer tank for the gas dissolved oxygen by photosynthesis production and pass through a cooling jacket and magnet pump respectively. Tubular photobioreactor was made up for 4 subsystems, including light supply, the buffer tank, the liquid circulation, and the temperature control. The tube, the light supply, the tube are made of clear acrylic material. Each layer of the tube was assembled with a row of LED light. The light intensity was continuously provided into position at the buffer tank 22 kilolux and at tubular coil 9.25 or 16.65 kilolux. The buffer tank is in a cylindrical shape and made of clear acrylic. It has a diameter of 29 cm and range of 98 cm. The bubble column is injected with gas bubble from fan head at the bottom and cause mixing, and it is designed as a counter flow reactor to enhance turbulence. The duty of liquid circulation is to circulate the microalgae suspension between the tubular coil and buffer tank to avoid the destruction of biological structure of algae and the pollution produced by pump rust. The plastic vane magnet pump with no shear force was employed to circulate the suspension at 0.75 cubic decimeter per second. Temperature control, which was connected to the cooling jacket via chiller, was regulated to maintain the photobioreactor temperature. Right after we're done with this slide, we move on to the result and discussion. The effect of temperature on microalgae cultivation. Increase in temperature caused microalgae to grow exponentially faster until they reach their optimal growth temperature. In this experiment, light intensity of 9.25 kilolux and without feeding carbon dioxide in tubular coil photobioreactor. The specific growth rate of controlling culture on temperature 305, 312, and 318 Kelvin is 1.1, 1.7, 1.42, and 1.11, respectively. Results show that the cultivating temperature of 305 was an optimum condition in terms of growth rate of Silacella sp PISPR 9427 without carbon dioxide. Right after we're done with this slide, we will move on to the experimental feeding carbon dioxide on photobioreactor. The effect of carbon dioxide on growth and productivity were studied for 36 days. The mass flow meter was used to set the gas flow through the fan head at 0.075 cubic decimeter per second. The emission analyzer was utilized to control the concentration of carbon dioxide gas of 0 and 10%. In the lab phase, the specific growth rate of 10% was slightly lower than 0%, 1 to 2 days. In the log phase, the specific growth rate of 10% was significantly higher than 0% because the high cell density possibly less tolerance to the amount of carbon dioxide that microalgae can withstand. During the stationary phase, about 35 to 36 days. The specific growth rate dropped dramatically both of 10 and 0%. The greatest specific growth rate of the controlling culture at 305 Kelvin with carbon dioxide of 10% and 0% is 0.307 and 0.167 respectively. From the table, was observed the biomass productivity in concentration of 10% was higher than without feeding carbon dioxide, with the biomass productivity were 1.75 times and carbon dioxide uptake rate were 1.85 times. The addition of carbon dioxide to the culture result in the increased specific growth rate and biomass productivity compared without a supply of carbon dioxide, thereby indicating the carbon dioxide addition have a positive effect. Conclusion. In this study, operation under condition to setting on the tubular coil photobioreactor for culture Silastella sp. Temperature of 305 Kelvin, light intensity of 16.65 kilolux, feeding air concentration carbon dioxide of 10%. The appropriate time for culture is 28 to 36 days, and carbon dioxide uptake rate of 10.6 gram carbon dioxide per cubic decimeter per day. More detailed investigation into growth parameter is being investigated in order to study growth rate and improvement in the tubular photobioreactor. These studies are necessary for future research on harvesting and process of microalgae by tubular coil photobioreactor. Thank you.
Thank you for your presentation. Professor?
Yes.
The team, any questions from the floor? So I have one question here. So you chose this specific strain. Why did you choose Coelestra? Did you see any different algae strains, or why did you choose this strain? Coelestra.
Okay. Silastella.
Silastella, sorry.
Silastella sp. To categorize in thermophilic species that withstand the high temperature. In this model, has a heat from pump, and Silastella can withstand with high temperature.
Okay. So high temperature. So what is the average temperature in Thailand?
I'm setting photobioreactor in indoor lab scale. Ambient temperature is about 30 to 32 Celsius.
Okay, fantastic.
But outdoor in the afternoon. Temperature is about 40 ประมาณ 45.
Yeah. So this is your pilot scale using tubular coil photobioreactor. I think they also have different way of cultivating algae, right?
Yes.
So are you planning to use to check the different or the most optimum method of cultivating algae, or I think in your conclusion, you'll say that you're going to look at different methods of cultivating. So what other techniques do you have?
In this model is combined with bubble column photobioreactor type and tubular photobioreactor type. Two model is different benefit. Tubular photobioreactor has a long tube. The carbon dioxide gas has increased dissolve rate of carbon dioxide gas and microalgae. Bubble column has a benefit of a high gas transfer rate.
Okay.
It's increased mix rate in the buffer tank.
Fantastic. So this is just a question. If you want to commercialize, example, you want to capture the carbon, like it's a carbon capture project. How big reactor do you think you need if you want to capture the carbon and use it as a commercial project? Do you have any idea, or you have not thought about it?
The concentration of carbon dioxide used in the study is equal emission carbon dioxide emission from full gas 8 to 10%. But in this study, I use carbon dioxide gas tank instead setting on the industrial.
Fantastic. Very nice project. Great. I wish you success commercializing this project. Fantastic paper. Thank you so much. Any other questions from the panel, from the floor? Professor Hussain?
I think there is no question. I think we can move to the next presenter.
Thank you.
Thank you so much. I think Professor, next is, I think 87. It's more of a video presentation. Okay, I'll play that video now.
Okay.
So paper ID 87, effect of pineapple drying using the ultrasonic vibrator. So he sent a video, so I'll just play the video. 87.
Dr. Patipa. Yeah.
Can you all see my screen?
Yes.
Okay, I'll play the video.
Faculty of Industrial Technology, Uttarakhand University, Thailand. Today, I would like to present effect of ultrasonic vibration on pineapple drying. The outline of my presentation divides 5 main parts. First, I will talk about introduction. Second, objective, methodology, results, and the last, conclusion. Let's start with introduction. Pineapple is a tropical fruit that is widely grown in various regions of Thailand. Pineapple is popular to eat fresh, but it can be preserved to extend its shelf life by making into canned fruit. Pineapple stir-fry, dry pineapple, and auto-preserved products. Pineapple dry is one of the most popular products made by small-scale removal of water content of product can reduce weight and volume of the final products, which in turn decrease storage and transportation costs. Pineapple has a relatively high water content, so you take a long time to dry. Spoilage can occur when the drying was poor and the moisture content could not be reduced to the required level. Ultrasonic vibration technology can be used to induce water movement in the product, resulting in further dehydration rate. The advantage of the ultrasonic are low power consumption, that heat build up at the vibration transducer. In addition, using low temperature can preserve nutrients in the product. It is of great interest to apply this technique to the drying process of pineapple. From the problem in the above issue, objective of this research is aimed to reduce the drying time by using ultrasonic vibration technology. Methodology from literature reviews. The ultrasonic setting in drying as shown in 3 methods. The first feature is suitable to set up ultrasonic vibration in a hot air dryer. In feature 2 and 3, suitable on vacuum dryer or microwave dryer. For my experiment, a laboratory hot air dryer was used to simulate conditions of a solar dryer for pineapple processing. Fresh pineapples were selected according to their maturity and color. After cleaning and peeling, they were sliced to pitch with thickness of about 10 mm by slicing machine. Set up transducer with a frequency 40 kHz and 50 watt. Was installed at the center of the wire mesh. Wire mesh size is 40 plus 40 centimeters. Operating temperature fixed at 60 degrees Celsius based on temperature in the solar dryer. The condition of experiment fixed temperature at 60 degrees Celsius. The volume of pineapple about 1.2 kg per tray. The final moisture content not over 13.7% weight bulk. Test without ultrasonic vibration and test ultrasonic vibration was applied continuously for 1 minute, every 10, 20, and 30 minutes, measuring and calculating the moisture content and drying rate. Results from experiments, this picture show relationship between the dry inlet and time of the vibration transducer was opening. The moisture content of the pineapple is reduced. Follow apply ultrasonic pulse for 1 minute in every 10, 20, and 30 minutes, and without ultrasonic vibration system. The fastest drying time was achieved for drying with the vibration on every 10 minutes. Shown at the red line. It was able to reduce the initial moisture content of pineapple from about 85% wet bulb to less than 30.7% wet bulb within 21 hours. This was 4 hours earlier than the normal drying without ultrasonic vibration. This picture shows evaporation rate of water in hot air dryer. The highest of drying rate is apply vibration for every 10 minutes. Get the drying rate of 48.57 grams per ounce. Conclusion. Therefore, an ultrasonic vibration is effective to drying rate. It was caused by accelerated movement of water in the pineapple to evaporate more quickly compared to normal hot air drying. Using of a vibration system help reduce the drying time. The high F reduction in the drying time and the moisture content are testing in hot air dryer with temperature control at 60 degrees Celsius at 1 minute. Apply vibration for every 10 minutes circle. However, future works might have an analysis of the texture and test characteristic of the dry product, the consumer demand, and analysis of energy consumption in the production process, and evaluation the economic feasibility. Acknowledgement. This work was supported by Faculty of Industrial Technology, Uttarakhand Rajabhat University, School of Renewable Energy, National University, and Chiang Mai University. Thank you for their technical and laboratory assistant staff at the Energy Management Engineering program. Thank you for your attention.
Great, thank you very much. And as you know, we are here assembled on the traditional territory of the Lekwungen-speaking people, Hisquaimo and Songhe.
Thank you for your presentation. Any questions from the floor? Professor, you have any questions?
Yeah, I have one question, Dr. Patipat. You are mentioning about your moisture content and that how much percentage of the moisture can be converted from the dry weight in the infection?
Okay, thank you for your question. For the start of the moisture content of the fresh pineapple is about 85 or 90% dry basis, wet basis. And for the dry pineapple is one in the level about 13.7% weight bound because the value is from the literature review is optimum for the preserved dry pineapple.
Okay. Okay, good. Thank you.
Pratibha, I have a question here. So when you say different variables, do you also see the size of your cuttings, or the size does not influence the process?
The sizing of biomass.
The cutting, the slice of pineapples?
Oh, okay. For the slicing is about 1 centimeter, because after dry is the shrink of the pineapple is about 0.5 or 0.4 centimeter is okay for the consumer. Is okay for the compare with the pineapple dye on the market.
Thank you. Good project. Any questions from the floor? If not, I think we can prepare for the next paper 101. Thank you, Pratibha, for your presentation.
Okay.
Good.
Thank you so much.
Thank you so much.
Miss Yatin. Yeah, Miss Yatin, are you here?
Okay.
Okay.
Good afternoon, everyone. My name is Yatin. Today, I would like to presentation on the topic of development of a dry-bed power supply system for pedal aeration of an aquaculture pond. In the topic consists of 5 parts. First, introduction.
Kevin, can you do the slide display, please? A full slide, full page.
Full screen, please.
Yes. Okay.
Hey, sorry. Good afternoon, everyone. My name is Yatin. Today, I would like to presentation on the topic of development of a dry-bed power supply system for pedal aeration of an aquaculture pond. In the topic consists of 5 parts. First, introduction. Second, material and methodology. Third, result and discussion. Fourth, conclusion. And finally, acknowledgement. Introduction. This sort of the levels in aquaculture is an important factor is carried at first.
Sorry, Kevin. The page doesn't move. You have to do the slideshow.
This show.
Yes, but it's next slide when you talk about introduction, it doesn't show the next page.
Okay.
We make it full screen. You just click on the the right
full screen on at the bottom.
In the bottom of the corner right side.
ต้องเล่นครับต้อง display PowerPoint ครับเพราะว่าหน้ามันไม่ขยับตามคำพูดหน้าไม่ขยับตามคำพูดคุณ
Try F5 try pressing F5
มันขยับยังคะ
ไม่คุณต้องกด F5
อ๋อค่ะ
F5 ของคอมพิวเตอร์
ค่ะ แล้ว
โอเค
แล้วกดตรงไหนคะ do
ในคอมพิวเตอร์คุณกดตรง F5
ค่ะ
F5
กดแล้วค่ะ
งั้นก็ต้องลองข้างล่างครับปุ่มข้างล่างของ PowerPoint อ่ะที่เป็นตัว Display Screen อ่ะเป็นหน้าจอ
Just you just or click the right mouse
มันไปไหมอะคะ
มันไปแต่มันไม่เต็มจอคุณมันไม่เต็มจอแล้วมันมีขึ้นคำพูดของคุณมาด้วยข้างล่าง
ค่ะ เดี๋ยวสักครู่นะคะ F5 มันเต็มจอยังอะคะ
มันยังเป็นเดิมครับมันยังมีจอมีคำพูดข้างล่าง แล้วก็ยังมีไอจอเล็กๆอยู่ด้านซ้าย
เดี๋ยวสักครู่นะคะหนูขอมันก็ขึ้นอีกเหรอคะ
ครับผม
เดี๋ยวขอ
โอเคเดี๋ยวงั้นเดี๋ยวนำเสนอ
ข้ามไปคนอื่นก่อนก็ได้ค่ะ
ข้ามไปก่อนโอเค
ค่ะ
The session chair she has some technical problem with her computer so she would like to ask others the next one presenter do it and then she will return when it's ready is that okay
Okay.
Sure.
Okay. Yeah, Dr. Bavin, you just call next on 93 ID number.
Yep, ID number 93.
Hello. Number 93.
Yeah, development of manufacturing gypsum board from coconut and water hyacinth fibers. Mr. Philip, Philin Hankunton. Yes, please. Thank you. You're ready?
I'm ready.
Thank you.
Kun Pailin, are you okay? Are you sharing the file?
Okay. Sorry.
Okay.
That's it.
เกวลินดูข้อความด้วยดูข้อความแชท
Good morning and everyone. Dear session chairman, organizing committee, and attendant of academic conference. Today I want to talk about my research development of sustainable gypsum board made from coconut fiber and water hyacinth fiber. My name is Thailin Haibutot. I am student development in the mechanical engineering RMUTI in Thailand. The topic to present are shown in the picture. Next, introduction. Thailand is a tropical country with summer of the most of the year. As a result, winter residents of building. The building has accumulated heat. The heat is connected into the structural roof, ceiling, and the wall. I need the storation of ceiling pan and the right wall in construction industrial. One of item is gypsum board to help in thermal fall reduction. Component of gypsum board includes plaster powder and was covered with sticky paper on both sides. However, installing a conventional ceiling on the wall pan could not provide the desired level of heat transmission reduction. Thus, additional insulation pan have been developed. The middle pan of gypsum board which be generally improved and development and further improvement and develop of gypsum board, such as cardboard sheets with aluminum foil, polyurethane insulation sheets, moisture resistant paper, mixed synthesized fiber. However, these insulator sheets are very expensive and poorly. Therefore, there have been research and development of ceiling and wall pan containing a mixture of the material that is natural fiber. This is because natural fiber are strong, non-toxic, and very composite of agriculture waste product. The material of mixture composite of cellulose, which is ideal for use as insulation due to its lightweight, ease of availability, and soluble nature. From research, there have been researchers who mix natural fiber in gypsum board. Literature review compost and silver, sugarcane and coconut fiber and use a reinforced material in the gypsum boards. Vidanupul use the coconut ceiling board product with thermal insulation copper. Blurred Vatanakul and Santik Chito property of natural fiber cement material containing coconut and oil palm fiber for residential building application. They are intended to be used as roof sheets. The objective of the research in the study to production. Most researchers use coconut fiber, and there is another type of fiber is water hyacinth fiber with insulating property. Is in a with it is a with material. Therefore, in this research, both type for where mix the gypsum powder will get a gypsum powder with mix of the natural fiber. Next experimental detail. Material and equipment as shown in the picture. Equipment use scanning electron microscopic SEM, universal testing machine, and thermal conductivity tester. the mixed proportion of GP incorporating CF and WHF used in study listed in table 1. The gypsum board waste combination of GP, CF, WHF, tap water, and sodium silicate. Next method, first step, coconut fiber and water hyacinth fiber form natural material. Wash off 10 times with tap water. Sun dry for 1 day before use. Cut to 20 millimeter in length. Weight of mass of the material according to table 1. Pour in material in the mixer. Put in the mold. Final step, we get a gypsum board. The curing time of 28 days and put to test. And the test procedure, water absorption and bending property, push off resistance, density, and thermal conductivity are based on standard. Next, the test result and discussion. Morphological and characteristics of gypsum board. The SEM image of CF and WHF show in the picture. It was found that CF has a smooth circular fiber with soft sickly surface. Also, the CF contain a grassy surface. For SEM analysis with the WHF, it was revealed that the WHF had a rough surface. Next, test result of density of gypsum board are shown in the picture. It was found that the use CF and WHF result in low density that the control mix due to its low bulk density and high porosity. The gypsum board containing CF and WHF has a low density. Additionally, increasing both CF and WHF result in a reduction of density of gypsum board. Test result of water absorption of gypsum board shown in the picture. It was found that the gypsum board simple mix with CF and WHF what a way higher water absorption than those of control mix and CTW. This was because the porosity value of CF and WHF are very high. Additionally, increasing both CF and WHF result and increasing the water absorption of gypsum board. All ratio gypsum board have not passed the water absorption standard. Bending force of gypsum board are shown in the picture. It was found that the transverse and longitudinal bending force of GF incorporated with CF 100 and CF 150 were higher than those of mix with WHFG, which also includes a combination CF and WHF. the GP with CF 100 and CF 150 mixer meet the bending force requirement at per prescribed standard. Test result of thermal conductivity of gypsum board shown in the picture. The thermal conductivity value of GP incorporated CF and WSF were found to be lower than that the control mix. Additionally, increased both CF WSF result in the reduction in thermal conductivity of gypsum board. Next conclusion, the density and thermal conductivity of GP containing CF and WSF were lower than that of control mix, but the water absorption and bending force were higher than. The GP containing CF 100 and the CF 150, the recommend due to its great quality in item low density, bending force, put off resistance, and thermal conductivity when compared to control mix and CGB. I would like to finish the present. Thank you for your attention.
Yeah. Thank you very much. Dr. Bevin, is the audience, do you have any question? The floor is open.
I have one question for you. What is the most what you call is used mixed with plasterboard used in Thailand? What is the most used material? So you have a gypsum mixed with some other materials, right?
In a proportion CF 100 and CF 150.
So when compared to your current using coconut husk and hycin, how can you improve? Is it that there's an improvement, or how much did you improve your thermal conductivity using a coconut fiber?
Improve thermal conductivity.
Is there any improvement? Did you do a test for that, or still to do?
Test to thermal conductivity.
Yeah, with the coconut husk.
Yes, test.
So your control is sorry.
Group CF overall.
Okay. Sorry, I think I missed this start. Okay, no worries. No worries for me. Any more questions from other floor?
I think there is no question. Okay, Miss Yatim is already here, so you can give the floor.
Thank you, Philin. Thank you for your presentation. Good project. Wish you all the best. And good luck. Thank you. Thank you so much. Next presenter, please.
Mr. Pilini, you just close your screen. Yeah.
So, Kevlin Yatin, I think.
Okay. Okay. Good afternoon, everyone. My name is Tin. Today, I would like to presentation on the topic of development of a dry power supply system for patchouli aeration of an aquaculture pond. In the topic consists of 5 parts. First, introduction. Second, material and methodology. Third, result and discussion. Fourth, conclusion, and finally, acknowledgement. Use of oxygen levels in aquaculture is an important factor. It carries effects to Nile therapy in a fish pond. Nowadays, most farmers prefer to use a utility grade to maintain the dissolved oxygen. It has certain issues. In the event of an aquaculture emergency or a utility grade failure, moreover, utility grade sources affect to electricity costs. So, energy management plays an important role because it solves these problems and reduces electricity costs. Most solar power generation technology is due to aeration system. It's important to control dissolved oxygen to appropriate levels. The researchers study about the reduction of energy consumption and power generation with solar energy technology and apply the dry system to reduce electrical energy for agriculture. The objective of this paper is design and develop a dry power generation system for the aerator and testing system efficiency as follows: 1. A power generation system from solar panels. 2. A grid electrical system. And 3. An energy storage system from batteries. And the last one, assessment of benefits from investment in aquaculture pond. Then I move on to material and methodology. First is design and management. Second is system efficiency testing. And the last one is economic assessment. In the first part, from the picture, you can see the dry below sharing system has concept is designed for a normal event and crisis event of 3 power sources to drive the 2 horsepower motor and store electrical power for at least 2 hours. In the normal event, energy usage of the aerator relies on the combination 2 power sources combined between number 1, solar panels, and number 2, electrical power from utility grid into the 3 kilowatt on-grid solar hybrid inverter 1, and pay electrical energy to load number 6. In a crisis event, system is already inactive if the event appears in the daytime. This system consists of the solar power system, 3 panels sharing through the 3 kilowatt on hybrid inverter 2 and into the battery module number 4. And then hybrid inverter inverts DC electric from the battery module as AC electric to supply the generator number 6. If the battery cannot charge fully in the daytime due to the low intensity of solar, the battery can charge by utility grid as an alternative energy source. Number 5. Next section is management. Normally, traditional cultivation of agriculturists always consumes the energy source from the utility grid between 9 a.m. to 11 a.m. and 1 p.m. to 6 p.m. and finally 8 p.m. to 6 a.m. become to increase energy costs. So the researcher has developed the rapid energy source and set initial time as new schedule to manage the generator system. The on-grid system starts with sunlighting until sunset at 8 a.m. to 5 p.m. and the on-grid system starts at 11 p.m. to 4 a.m. And then the battery system runs instead of utility grid to save electricity from 4 a.m. to 6 a.m. System efficiency testing. System efficiency is tested to find the efficiency of both normal event and crisis event follow the generator is turned on during the day between 8 a.m. to 5 p.m. run on solar power system and utility grid system. Situation 2 is run on utility grid system only between 11 p.m. to 4 a.m. and situation 3 use the battery system only between the time between 4 a.m. to 6 a.m. The parameters were investigated and measured and recorded every 10 minutes for 3 days. The analysis of system efficiency is shown in this equation. The output parameter is power output of generator, while the input parameter is power input for each of the 3 power resources. And the last section, economic assessment. Economic assessment to analyze the investment for the agriculture plant power generation system and to design the criteria for system installation, where IC is investment capital, Thai baht, P is profit baht per cycle. Then in the result and discussion divide 3 parts. 1. Design result of the driving power system. 2. Testing system result and 3. Economic analysis result. Design result of the driving solar power system. The Nara Tribal Fish Pond in a located in Sansai District, Chiang Mai Province, Thailand. The 10 solar panels are installed on 14 solar panels in the picture A. Picture B is aerator and water, and picture C is direct control system. Looking the chart, you can see the aerator running on the on-grid system has input or from solar power system is slightly swing dependent on solar intensity. The current level and power that have similar characteristics divided as follow. The current power of solar power system are directly vary with solar intensity. And the efficiency of OnKit is 89.94%. This slide shows utility grid system. The utility grid is supplied to the aerator at 11 p.m. to 4 a.m. The characteristics of the wanted current, power, as well as energy consumption are similar with the OnKit system on the daytime, and the efficiency of utility grid is 90.61%. This graph shows the battery system. In this case, all power and energy in picture is indicated that electrical power from battery and the aerator uses have proportional relationship, and the efficiency of this system is 89.17%. In the last section of result, investment capital and electrical power saving in payback period for that. Investments of the debit system, alter material has investment of the debit system has alter material and equipment. All often have value as 147,000, and operating system is one production cycle, and theoretical power is 6,390, and payback period is approximately 22 cycles. Finally, conclusion, the debit system is poorly designed performer with the consist of 3 electrical energy sources, including the solar panel, utility grid, and the battery module, 2 pieces. And the efficiency of the system is 89.94% of the OnKit, 90.61% of utility kit, and 89.17% of the battery and solar store up to 3,541.3 watt-hour for the classic event, approximately 2 hours. Finally, investment budget of 147,000 Thai baht and payback period at 23 product cycles. Acknowledgement. School of Renewable Energy Major University and the scholarship for graduate student in 2018, and finally, Smart Energy and Environmental Research Unit. Thank you for your attention. Do you have questions?
Thank you. Thank you for your presentation.
Okay.
Any questions?
Okay, I have one question, Ms. Yatin.
Okay.
Thank you for your nice presentation. My question is, you have done any experimental analysis, and how do you verify your result that this could be effective for the commercialization or some other research purposes? Thank you.
I can please slowly.
Okay. My question is, do you have any experimental analysis and the validation of your results so that it can be further used for any research or commercialization purposes? Is it clear, my question? Do you have any comparison, your result, with some other simulation or experimental? Any comparison?
What is
How do you verify your result? How do you verify your result? I'm sorry, I think yeah. You have you verified your result? Compare your result. Compare your result. Okay, I'm sorry. Okay, okay. Okay, floor is open.
Can check.
No problem. No problem.
On share.
Okay, floor is
No
open
worries.
for others. Please.
I've got no questions for now. Anyone else? I think it's okay, Professor. That's good. That's good. Your presentation. That's good. Thank you, I think. Lot of it's good presentation. No worries. Good luck for your thesis.
Yeah, since there is no, it's okay, no problem, no worry. Since there is no more presenter,
Professor,
Dr. Bevin.
sorry, Professor. I think Sri Punya he didn't finish his presentation earlier, so he wants to
now he is
present, I
available.
think. Yeah, Sri Punya, are you available or?
No. Still, he is not available.
Oh, he's here. He's here. He messaged.
Okay,
he wants to. Okay, you can if you can complete your presentation, Sri Punya.
Yeah. Okay.
Sri Punya, are you ready?
Yeah. Okay. Can see my slide.
Yeah.
Yeah, I slide to the methodology. The methodology, the first injection chamber, porous absorber PA, conversion zone HE, PE, installers, exhaust gas outlets, and the exhaust gas outlets. The PE, the PE and the PA are made was the alumina chloride as porous matrix. The SUS 300 flow stainless tube is the tube bank heat exchanger of tube bank. A case study diameter of the porous absorber DPA, the thickness of the porous emitter HPE, volumetric P mixed gas velocity Vmix, diameter of the porous emitter DPE, equivalent ratio fee, water flowless feeds into his exchanger QW. The investigates the temperature profile of porous burner T and effectiveness of the heat exchanger epsilon. Result and discussion. The show effect of DPE on T, effects of DPE. The X acid is experiment equivalent, Y acid is temperature profile T. The test condition show in slide. The result show that the 3 watts deficit is decreasing DPE because the low porosity of PE was increasing energy absorption. The right picture show effect DPE on epsilon. The waterfall, the epsilon was decreases as increasing DPE because decreases of the flame temperature brought the energy slightly absorption between the working point of heat exchanger and the temperature frame. The second result indication, this is show effect of phi on the tree. The result show that the T was increases as increasing phi because complete combustion may occur when mixture mixture of air and LPG is produced. The right picture, this is show the effect of phi on epsilon. The word found that the epsilon was slightly increases as increasing phi because the slight absorption between the working fluids of of heat exchanger and the high temperature frame. Final result, the effect of QW on tree. The result showed that the T tenderness of remains constant as QW increases because restriction in the nature of the heat transmission between the working fluids and the high temperature frame. It is show effect QW on epsilon. It was flow that the epsilon was increased with QW increasing because the system has increases amount of water inlet. This is explained by the difference as shown in the equilibrium ratio equation. Conclusion: the temperature profile was increased as increasing equilibrium ratio, but increases as increasing DPE. The effectiveness of the heat exchanger was decreased as increasing DPE, but increases as increasing phi and QW. Moreover, the epsilon increased with installed the PE. Thank you very much.
Thank you, Mr. Siripunia, to finish your presentation nicely. Thank you. The floor is open. Any question, please? Dr. Bevin, do you have any question or?
I'm good.
Okay.
Thank you, Siripunia.
Finally, he has finished his presentation. Yeah, finally he has finished his presentation. Nicely. Yeah. Okay. If there is no question, I think from my side, thank you, everyone. Dr. Bevin, can you say something for the audience?
Yeah. Thank you so much to all the participants. Very good research we saw today. Keep up your good work, and hope we can see you in the next seminar. Seminar we can see all in person. So thank you very much for participating. And good luck. Good luck.
We expect. Yeah. Okay.
And thank you, Professor. Also, Professor Altaf.
Yeah, no, it's okay. Thank you. Thank you very much. Okay. Hope to see you or hope to meet you again. Okay.
Thank you.
Okay.
See you.
Thank you. Bye. So see you. Bye bye.
Take care.
Thank you, Bhavin.
Thank you, Dr. Arun. Fantastic.